Hello, welcome to lesson 12 on the topic Permutation Combination. In lesson 11, we were discussing the concept of formation of numbers. I hope you have paid attention and understood that concept properly. Now let me take you to the next concept. Okay, the number of permutations of n things, the number of permutations of n things out of which p are alike of first kind, q are alike of second kind, r are alike of third kind, and so on. Okay, so now we are saying that out of these n things, p things are identical, q things are identical, r things are identical. Now what will we say regarding the number of permutations? So the number of permutations or the number of arrangements is n factorial divided by p factorial into q factorial into r factorial. Okay, that is, as compared to a normal case where we use n factorial, what is the change? The change is very simple, very simple. Divide by the factorial of the number of things that are identical. I repeat, divide by the factorial of the number of things that are identical, right? So n factorial divided by p factorial into q factorial into r factorial. Now let me take a very basic example. Suppose we have a 5 alphabet word like apple. Now the question is, in how many different ways can the alphabets of the word apple be arranged? So my answer is 5 factorial. And since there are two p's and they cannot be differentiated because they are identical, we will divide it by the factorial of the number of identical things. So the number of ways in which the alphabets of the word apple can be arranged is 60. Right? If you remember, I had explained the basis of permutation, the arrangement of things, by taking the example of boys and girls. All those concepts that we learnt there, they can be used along with the concept of identical things. The only aspect to be kept in mind every time is, do whatever you would have normally done, but divide by the factorial of the number of identical things. Now let me tell you, this concept, though it is very simple, it has got some beautiful applications. I will share some of them with you. It has some beautiful applications, right? And I hope you would appreciate when you learn about those applications. But before I take you to those applications, let me tell you some good questions based on this concept. Okay, some examples. Alright, so my first example, mathematics, mathematics. The alphabets of the word mathematics is being arranged or are being arranged. You can take different questions. The first is number of ways, right? So what is the number of ways? Now whenever you get questions like these, I have a suggestion. Please write down the number of alphabets of each type so that you don't make a mistake regarding the total alphabets available. So what I will do, there are 2 M's, there are 2 A's, right? There are 2 A's, there are 2 M's, there are 2 T's, there is 1 H, there is 1 I, there is one C, there is one S. Okay, so 2, 4, 6, 7, 8, 9, 10, and this is 5, 6, 7, 8, 9, 10, 11. So what have I missed? There are 2 M's. Okay, there is one E. There is one E. So 6 and 11. This is also 11. So my suggestion is, please make sure that the count of the alphabets match, so that you don't make a mistake. All right. So the first question, number of ways. So what is the number of ways? 11 factorial. There are 2 M's, so 2 factorial. There are 2 A's, so 2 factorial. There are 2 T's, so 2 factorial. Can I stop here? Absolutely. This is going to be my final answer. 11 factorial divided by the cube of 2 factorial. Okay? Right. Now let me take the second example. What is the second example? All the consonants are together. Okay? All the consonants are together. Right. Now what we will do? Have we learned the application of permutation where all things are together, a group of things? Absolutely. Taking the example of boys and girls, the same thing has to be applied here, right? So a good question. All the consonants are together. So what we will do? We have M, M, T, T, H, C, S. So we have this group, and then we have A, I and E. So 4, 7 and 11. I would encourage you that every time you please check the count so that you don't make a mistake. So I have a group of 7 things, but it is a group, and then I have 4 things, right? So how many things are to be first arranged? First I am talking about the arrangement of 5 things, right? First I am talking about the arrangement of 5 things. Out of those 5 things, there are 2 A's which are common. So divided by 2 factorial and multiplied by. In how many ways can we rearrange this? In how many ways this can be rearranged? So these 7 alphabets can be rearranged within this group. In how many ways? 7 factorial, 2 M's, so 2 factorial, 2 T's, so 2 factorial. Right? So you don't have to worry. Sometimes students will get into the mode where they try to memorize these things. Absolutely not required. It's very, very logical. If you have understood that concept, and if you have understood the concept where identical things are there, repetition, you can combine both and easily handle the questions, right? So all the consonants are together. Okay? Let me take a third example. Let me see how many of you remember what we have been doing in permutation combination, and we have been talking about discussing some very important, interesting results, right? The third one, no 2 vowels are together, and suddenly, because students are not clear or conceptually, suddenly they find such questions difficult to handle. Absolutely easy, provided you are conceptually clear. No 2 vowels are together, right? So what we will do? We have got M, M, T, T, H, C, S. We have got A, we have got A, I and E. So the condition is on the vowels. What have we learned? We will first arrange the consonants, right? We will first arrange the consonants. So we have got 7 consonants. They can be arranged in 7 factorial. They can be arranged in 7 factorial divided by, there are 2 M's, so 2 factorial. There are 2 T's, so 2 factorial. Now once the 7 consonants are arranged, if you want I will do this here for you. Once the 7 consonants are arranged, 4, 5, 6, 7, 8, there are 8 places for the vowels. Remember, there are 8 places created for the vowels. Now the 4 vowels have to occupy these 8 places. So the first vowel can occupy a place in 8 ways, the second in 7 ways, the third in 6 ways, and the fourth in 5 ways. So 8 into 7 into 6 into 5. Do I have something that is identical? Absolutely, 2a's, so divide this by 2 factorial. Alright. If you remember that example of boys and girls, or the number of books being arranged on a shelf, what we can do, we can also write it as 7 factorial into 8p4 divided by 2 factorial into 2 factorial into 2 factorial. So both these results are the same. Correct? So students, this concept where there are a number of identical things, alright, being arranged, the permutation of a number of identical things is a very interesting concept, and it's a very popular concept, right? In the subsequent lesson, we will be looking at some very good application, very interesting application of the concept of identical things. Thank you.